students, I welcome you to the objective type questions based on Coulomb's law. Please check my previous video. The link is given in the description box. Okay, now we can go into this question. Two equal charges are placed at a separation of 1 meter. What should be the magnitude of the charge so that the force between them equals the weight of a 50 kg person? So given is Q1 is equal to Q2. That is, two charges are equal. So let it be Q. Okay, two charges are equal and let it be Q. And we have to find the magnitude of this charge, and the distance is equal to 1 meter. So you have to find out the magnitude of the charge. These are things given. So we know that Coulomb's law, F is equal to K into Q1 into Q2 divided by R square. Okay, so K is equal to, Coulomb's constant is 9 into 10 to the power of 9 Q square divided by 1 the whole square. So which is equal to 9 into 10 to the power of 9 Q square. Okay, Newton. And the next given thing is, they are given that mass is equal to 50 kg. Okay, so weight is, we know weight is equal to m into g, where g is the acceleration due to gravity. So g is equal to 9.8 meter per second square. Okay, so this weight is nothing but the downward force due to gravity. So it is equal to 50 into 9.8, which is equal to 490 Newton. So this is also the downward force due to gravity. And one more thing they are given in the question is, both the force are equal. Okay, so this force is equal to the weight of the body. Okay, so 1 and 2 are equal is given in the question. F electrostatic force is equal to weight of the person given in the question. So just equate 1 and 2. So when you equate, what you will get? 9 into 10 to the power of 9 Q square is equal to 490. Okay, so therefore Q square is equal to 490 divided by 9 into 10 to the power of 9. So which is equal to 5.44 into 10 to the power of minus 8. So we get Q square is equal to 5.44 into 10 to the power of minus 8. So therefore Q is equal to square root of this value, 5.44 into 10 to the power of minus 8. Then what will be the answer? After taking the square root, we'll get the answer to 2.3 into 10 to the power of minus 4 Coulomb. So this is the answer. This is the value of the charge. Okay. So first you are writing the Coulomb's law, then you are writing the equation for weight is equal to m into g. Then equate both this 1 and 2. Then do the mathematical calculation. Then you will get the magnitude of the charge. Okay. Okay. Next question is, two equally charged identical metal spheres A and B repel each other with a force of 2 into 10 to the power of minus 5 Newton. Another identical uncharged sphere C is touched to B and then replaced at the midpoint between A and B. Okay, two equally charged. So let me consider two equal charges A and B. So two equal charges A and another one charge B. Okay, so they are two identical charges. So they repel each other with a force of 2 into 10 to the power of minus. So the given force is equal to 2 into 10 to the power of minus 5 Newton is the repulsive force between these two charges. Another identical uncharged sphere C. Okay, so let the two charges separated by a distance of r. Okay, and force between them is 2 into 10 to the power of minus Newton. Another identical uncharged sphere C is touched to B and then replaced at the midpoint between A and B. Okay, so you have considering another charge, that is an uncharged body. So uncharged body C, okay, comes in contact with the charged body B. So two equally charged, they are given the question. So let it be Q be the two charges, two equal charges at a location A and B. And we have B charges Q and C is an uncharged body. So they are touching. So due to conduction process, charges will be equally distributed between C and B. So after conduction process, you will get C and B value both Q by 2, Q by 2. Charges in both C and B will be Q by 2, Q by 2. Okay, so after in contact, result. So result of contact. Okay, after they are touching each other, the charges will be equally distributed. Now what is the charge of C? Charge of C is Q by 2. Now this charge C is then placed at the midpoint between A and B. Okay, they are placed midpoint. C is placed at midpoint between A and B and the charge is Q by 2. Okay, now the separation between A and B is R and the separation between Q and C will be R by 2 and this will be R by 2. Okay. Okay. The direction of force between C and B. Okay, what will be the direction of force between the C and B? Okay, so what could be the direction between A and C? So A is also positive charge and C is also positive charge. So C experiences a repulsive force due to charge A. So the C is repelled by A. So we'll get F C A. Okay. Similarly, the C experiences a repulsive force due to B. C is also positive, B is also positive. So C is repelled by B. Repelled by B in this direction. This is F C B. Attractive means C will be attracted towards B and the force will be towards B. Here it is repelling force because they both are like charges. Both are positive charges, so it is repelled. Okay. Okay. Then what will be the force between A and B? A and B also will be repulsive force between A and B, and the value is given to be F equal to 2 into 10 to the power of minus n Newton. So what is the first question? The first question is, what is the direction of force between C and B? So what is the direction of C between C and B? Along CB, along CA, no force between C and B. So what could be the answer? The direction of CB is along CA. Okay, CB is along CA. So the C is positive, B is also positive. So C experiences a repulsive force. Okay, so C experiences a repulsive force due to B. Okay, it will be repelled due to B. So it is along the direction of AC. Okay, so answer is B, along AC direction. Okay, CA direction. Then next question is, find the magnitude of FCA. We have to find out what is the value of FC and A. Okay. Okay. So apply Coulomb's law. We'll get F is equal to K into Q1 Q2 by R square. Okay. So what is the charge at C? Charge at C is equal to Q by 2, and charge at A is equal to Q. It is given in the question. Q is equal to Q and QC is equal to Q by 2. So now we have to find out the force experienced by the charge CA due to A. Okay, so K into QC charge, QA charge divided by its distance. So what is the distance between C and A? Distance is RAC, distance is equal to R by 2, right? R by 2 the whole square. So which is equal to, okay, K into what is the charge of QC? It is Q by 2. A charge is Q divided by R square by 4. So which is equal to K into Q square divided by, okay, 2 into R square by 4. So 4 goes to the numerator, so we'll get K Q square by 2 R square into 4. Okay, so just cancel it. So the answer is, I'll write it here, answer is equal to K Q square 2 by R square. Okay. What is this K Q square divided by R square? It is nothing but F value. Okay, this is nothing but the Coulomb's formula for two identical charges, F. So which is equal to 2F. So therefore FCA is equal to 2F. Okay, so the option is A is the answer. So they are given first two charges, identical charges they are given. Then you are taking uncharged body brought in contact with the identical charges. So when the two uncharged body and one is uncharged, other is charged, when there is a contact, conduction takes place. So charges will be equally distributed between the two bodies. So C becomes Q by 2 and B also becomes Q by 2. So now it is placed in between this A and B. Now what is the force experienced by this C due to this B? So what happens? B and C both are positive. So C experiences a repulsive force due to B. So it is repelled away. Okay, so option, so it is repelled away, it is along CA direction. Now what is the magnitude of FCA? So magnitude of FCA is, by Coulomb's law, FCA is equal to K into QC QA divided by the distance between them. So QC value is Q by 2 and QA value is Q. So just substitute it. Then we'll get the answer as 2 times that of F. So next, in an equilateral triangle, the charges placed at the vertices of the triangle is given as QA, QB, QC. Okay. Okay. Now the charge QA value is 5 into 10 to the power of minus 7 Coulomb. QB is minus 2.5 into 10 to the power of minus Coulomb, and QC is 1 into 10 to the power of minus Coulomb. Okay. Okay. Now we have to find what is the force experienced by this charge C. Okay, what is the force experienced by this charge C? And the side is of 5 centimeter. All the sides is 5 centimeter. And you have to draw the resultant electric force at QC due to QA and QB. Okay, this is your QA, this is your QB, and this is your QC. So what is the electric force at point C? Okay, at point C, what is the resultant force experienced by the point C due to A and B. Okay, first let's check it out for A. So A is of positive type and C is also positive. So the force between two like charges, two positive charges, will be a repulsive force. So A will repel the C. So the force experienced by the C due to A is repulsive force. Okay, it will be repelled. Now you can check it out for B. So B is negative, it is a negative, and C is positive. So like and unlike charges, negative and positive attracts. So C is attracted by B. It is attracted. Okay, this is your FCB. Then what could be the resultant? Resultant will be between FCA. The resultant vector will be between FCA and FCB will be a resultant vector. Okay, this is your resultant F dash. So the angle found will be 60 degree. So 60 degree, total 120 degree. Total angle is 120 degree. Okay. So you'll get the resultant diagram F dash in this way. Okay. So two like charges will repel and one unlike and one like charges, that is unlike charges, will attract each other. So at the point C, A experiences an repulsive force. So it is point. So C is repelled away from A. So you are drawing away from A in this direction. When you compare to B, it will be attracted. So C is pulled towards the B. So the force is in this direction. Resultant will be between this FCA and FCB. Okay. Okay. Next is three charges each equal to Q and Q are placed at the three corners of a square of side A. The resultant force at D is along. Okay. Three charges. So just I'll change the question. 4 charges. Okay. Okay. 4 charges are placed at the 4 corners. Okay, sorry for this. 4 charges are placed at the 4 corners of a square of side A. Okay, so side is A. And the resultant force at D is, what is the resultant force experienced at D? Okay, so first check it with A. A is Q, positive, and D is also Q. Now what happens? The force experienced by D is repelled. So A repels the D. So what is the force experienced by D? We have to check it out with respect to all other charges. So now D is also positive, A is also positive. So D will be repelled by this A. So D will be repelled by this A. This is your F, D, A. Okay. Okay. Next. What could be between B and D? Both are positive charges. Both are like charges. So when there is a like charges, again B will repel this D. Okay. B will repel this D. This is your F, D, B. Okay. Now check it with C. Q, Q. Both are positive charges. Again, C repels the D. This is your F, D, C. Okay. So now the resultant between FDC and FDA will be along FDC. Okay. You have your FDC, FDA. Okay, and the resultant between them FDP. So not resultant, the force experienced by the B due to D will be in this direction, and the resultant between FDC and FDA vector also will be the same direction as that of FDB. Okay, so F dash is the resultant of FDC vector and FDA vector. Resultant also will be in this direction along FDB. Okay. Okay. Now the angle formed between them will be 90 degree. Okay, so angle formed between them will be 90 degree. Okay. The resultant force at D is along. Now, okay. Now let's come to the question. The resultant force along D is along AB, AD, CD, AB. It is along in what direction? BD. It is not along AD. Resultant is not along. Resultant is F dash. Okay, it's along which direction? This direction. It's along DB direction. So option is D. Okay, so D, first we'll check with A. It is also positive. So what? A will repel this D towards here. Now check with B. It is also positive. So B will repel the D along in this direction. Now check it C. C is also positive. D is also positive. So C will repel this D along in this vertical direction. Okay. Now the resultant of FDC and FDA will also be in the direction of FDB. So resultant force at D is along BD direction. Okay. Okay, next is force on the positive charge placed at the center of the square is. At the center of the square, let it be O, and a positive charge, test charge is placed at the center plus Q. Okay, now you have to find out what will be the resultant of this center charge. Okay, force experienced by this centrally placed charge plus Q, and you find out what will be the resultant of this. Okay, first we'll check with A. So plus Q, this also plus Q. So what does A do? A will repel this charge. Okay, this is your F O A. So this is positive, this is also positive. Then what happens? Positive will repel. So this A will give a repulsive force to the center Q O. Okay, so it will be repelled in this direction. Okay, next we'll come to the next one. Okay, now with this C, it is a negative, and what is center charge is positive. This is positive, this is negative. So positive negative attracts. So the C attracts the O. It is also in the same direction. F O C. Are able to get center charge, the test charge, positive charge. So what is the force experienced by this positive charge due to this positive charge at A? So both are positive. So A will repel this positive towards C. Now compare the center charge with the C. Okay, charge at C is minus Q. So minus Q plus Q. So unlike charges, one is negative, one is positive. So attracts. So C will attract this positive charge towards it. Okay. Okay, now we can see the next diagonal. Now B charge is positive and this positive charge at center. So two like charges will repel. So this B repels this center charge. Okay, B repels this center charge. Okay, so its value is FOB. This B will repel the O. Okay, next we'll check with this D. D is negative and Q is positive. So what does D do? D will attract the center charge towards itself. FOD. Okay, are you able to get? So this is the resultant of all this attractive or repulsive, resultant of all the forces. Now we have to write the resultant diagram will be between, this will be a resultant. F dash will be resultant. So now check out the direction of F dash, where it is. It is perpendicular to C and D. So the option is D. Resultant F dash is perpendicular to C and D. Okay, are you able to get? Center charge is positive. If it comes into with experience with a positive charge, then it gets repelled. The center charge gets repelled. When it comes into contact experience with a negative charge, then it will be attracted. So based on this, we'll get the force direction like this, and the resultant force in perpendicular to CD. Okay, now find the next one. Find the total force at center of the square. Okay, you have to find the total force at the center of the square. Again, you are placing a positive charge there. Okay. Okay. So, let the positive charge plus Q. So, what does this plus Q? 5, both are positive, plus 5 microcoulombs, right? So, this charge 5 will repel this Q. Be repelled in this direction. Let the center be O. So, FOA. Now, what happens to this charge C? It is also 5. And this is plus Q. So, what it does? It repels. This 5 coulomb will repel. Okay. So, both the charges 5 microcoulomb, 5 microcoulomb. Both the charges are equal in magnitude. So, the amount of charge FOC and FOA will be equal but opposite direction. Will be equal but in opposite direction. Just I'll draw it here. Okay. So A, D, B, C minus my microcoulomb. This is minus 2 microcoulomb. This is 5. And this is 5 microcoulomb. So placing a center test charge, positive charge at the center Q at O.O. So what it does? So both the charges, right? Both the charges positive and positive. So it gets repelled like this. Okay. FOA, and this C will repel this Q because both are positive charges. So it will be FOC. So both the 5, this is also 5, this is also 5. So both the magnitude of the charges will be same but in opposite directions. Okay. Similarly, minus 2 and plus Q. This B minus 2, this is plus. So what it does? This plus charge is attracted. Similarly, this is minus 2, this plus. So this plus charge will be attracted. This is your FOD. So the attractive force is also equal but opposite direction. Here the repulsive force along this direction is equal and opposite direction, and this along this diagonal BD, the attractive force is also equal and opposite direction. So they get diagonally, they get cancelled. Okay. So the net force is equal to 0. Why it is 0? FOC is equal to FOA. Equal but opposite direction. So diagonally they get cancelled. Similarly, FOD and FOB are equal but in opposite direction. So they get cancelled. So this gets cancelled. This gets cancelled. This gets cancelled. This gets. So net force at the center will be 0. Okay. Next, 2 like charges of 1 into 10 to the power of minus coulomb and 9 into 10 to the power of minus coulomb, okay, are separated by a distance of 1 meter. Then find the point where the force experienced by a charge at the point is 0. So 2 like charges. So 2 charges, okay, 1 into 10 to the power of minus 9, let it be A, and another one charge, let it be B, which is 9 into 10 to the power of minus 9 coulomb. Both are separated by a distance of 1 meter. Given question, they are given it is separated by a distance of 1 meter. R is equal to 1 meter. Okay. Now we have to find a point where the force experienced by a charge at that point is 0. Okay, so force experienced by a charge, we are going to place the charge in between A and B. Okay, between A and B we are going to place some other charge. So you have to find out at what distance. By placing the third charge C, you are going to place a third charge C. See, its charge is Q. Okay, third charge C, its value, let it be Q. So you have to find out third charge at C. Okay, at what distance it is 0. Okay, then find the point where the force experienced by a charge at that point is 0. So at what distance the force experienced by this third charge is 0 along the line AB. So along AB, by placing a charge, place a charge Q. So at what distance the force is 0. So at some point you have to find out. So at what distance point the force becomes 0. Okay. Force experienced by this third charge becomes 0. So in between A and B you are going to place a third charge. At what distance the third charge experiences a 0 force. Okay, 0 force we have to find out. Okay, so we don't know where the distance, so randomly we take it as x. Let x be the distance for the third charge somewhere here. We don't know the distance, we have to find out this distance. Okay, and this from here to here, this is x and this is 1. So what will get? 1 minus x. Between this Q and B it will be 1 minus x. Okay, between A and Q will be x meters, and this here between this and this will be 1 minus x meters. Okay, now we can, so this is a positive charge. Okay, now the force experienced by this positive charge due to A will be along in this direction. Okay, it's experienced by this charge. Let it be this charge placed at O. So F OA will be along this direction. Similarly, the positive charge, this is also positive charge, B is also positive charge, right? So it also experiences a repulsive force. Q experiences a repulsive force in this direction. F O B. Okay, then you can apply the Coulomb's law. So apply the Coulomb's law. Okay, K into 1 into 10 to the power of minus 9. So this FOB will be equal to FOA. Okay, both will be equal in opposite direction. Okay, so yeah, K into 1 into 10 to the power of minus 9 into Q. This is nothing but the force between your O and A. Okay, so K into, this is the force of A and this is the force of placed at O is Q, divided by what is the distance between the x square is equal to. Okay, so FOA is equal to FOB, both are equal. So K into, just again substitute the values, K into what is your O values Q, B values 9 into 10 to the power of minus 9, divided by the distance between them is 1 minus x the whole square. Okay, now you can cancel the common terms. Q gets cancelled, K gets cancelled. The remaining will be 10 power minus 9 by x square. It will be equal to 9 into 10 to the power of minus 9 divided by 1 minus x the whole square. So again we have 10 power minus 9, 10 power minus 9. You can cancel it out. The remaining will be 1 by x square will be equal to 9 by 1 minus x the whole square. Okay, just we can do the mathematical calculations and find out the answers. So just take the cross multiply it, then we'll get 1 minus x the whole square is equal to 9x square. Okay, now square root, take square root on both sides, both left side and right side. You take the square root, then it will get 1 minus x is equal to 3x. Okay, therefore 1 is equal to 4x. So x is equal to 1 by 4 is equal to 0.25 meter. So at a distance of 0.25 meter. Okay, so the x distance is at a distance of 0.25 meter. This charge will experiences zero force. So when you place this third charge at a distance of 0.25 meter, the force experienced by this 1 into 10 to the minus Coulomb and Q charge will be 0. Similarly, 1 minus this 0.25 meter distance, the force experienced by the Q charge will be 0. Okay, so exactly at 0.25 meter you have to place the third charge. So you are finding the value of this x. So what they are given is, they are given the two charges and they asked to find out at what distance if you place a third charge, the force experienced by the third charge will be equal to 0. What distance you have to place. So you have to finding the distance, it gives the answer as 0.25 meter. So at 0.25 meter, force experienced by the third charge will be equal to 0. Okay. So coming to the next question. Okay, 3 charges plus Q plus 2Q plus 4Q are connected by strings. So these are the strings. Find the tension in the string AB. You have to find the tension in the string AB. Okay, so assume the system in equilibrium, then tension on charge A is equal to electric force on the charge A. Okay, so tension on the string AB is equal to the force experienced by A. Experienced by A, which is equal to FA. Okay, so let the distance be. Okay, just you take the distance B D, and distance between this also D. Okay, and distance between A and C will be D plus D 2D. This data is missing. Actually, it's good. The distance will be D, and distance between A and C will be 2D. Distance between A and C will be equal to 2D. Okay. Okay. Now force experienced by A. Okay, so we are going to find the force experienced by A. So what are the force experienced by A? The charge at A plus Q will experience as a force due to B as well as due to C. Okay, so F AB plus F AC. Okay, this A charge at A will experience a force due to this B as well as due to this C. Okay, what force? Obviously it will be a repulsive force. Okay, so FAB also and FAC both will be along AC direction. Okay, FAB also will be along AC direction, along this direction, and the force experienced by AC also will be along in this direction. That is, A will experience a force due to B. So what force it experiences? A gets repelled. Okay, so A gets repelled by B. It will be moving away from B. That will be repelled. Okay. Similarly, C is also having a positive charge. So what does the C does? C also repels the A. Okay. So FAB and FAC. So FAB plus FAC will be the force experienced by this by the charge at A. Okay, now we can just substitute the values in Coulomb's formula. We'll get K into, what is QA? QA is Q. Okay, just I'll write the first formula, then I'll substitute QA QB by A R square plus K into QA QC by R square. Now just substitute it. K into, what is the charge at A? Charge at A is Q. Q into charge at B is 2Q divided by distance between them is D. So D square plus K into charge at A is Q, charge at C is 4Q divided by 2D square. Okay, 2D square. Then we can simplify this. We'll get K 2Q square by D square plus K 4Q square by 4D square. Okay. So this 4 you can cancel it out. Then D square will be there. Then we'll get K 2Q square plus KQ square. So which is nothing but 3KQ square by D square. So therefore tension AB is equal to FA is equal to 3KQ square divided by D square. Okay. So they are saying that three charges are connected and they placed at some distance D, and they asked to find out the tension along the AB. So tension along the string will be equal to the force experienced by this A charge. So A charge experiences a force due to B as well as due to C. Okay, so apply in the Coulomb's formula. The charge given, values are given, just substitute the values and simplify it. Then you will get the answer as 3KQ square by D square is the answer. Okay, thank you students. The next video we will see a similar objective type questions related to electrostatics. Please find the link given in the description box. You can find and like and subscribe and share with your friends. Thank you so much.